The percent mass or percent composition of anything can be determined. For example, I might have a bag of Skittles that is 25% red, 35% orange, 10% green, and 30% purple. Percent composition just tells you how much of one item you have compared to all of your items. It can also be called a percent mass, and we can very easily do these percent compositions for any formula, and it will tell us exactly what percentage of carbon or hydrogen or oxygen or any other element that we have in a certain compound. This percentage never changes, and if it did change, then it wouldn't be the same thing anymore. And we looked at this idea earlier. We talked about the law of definite proportions. So if I have CH4, I always have the same percentage of C and the same percentage of H. Otherwise, it would not be CH4. That's the law of definite. It always stays the same. An easy way to determine the percent composition of any molecule is to use the periodic table. You just take the atomic mass of the element and divide it by the total mass of the compound. This will then give you the mass percentage, which is why it's called a percent mass or a percent composition. The one thing you have to remember is that if there's more than one element, you have to multiply the mass of one element times however many you have. For example, if I have CaCl2, in order to determine the percent composition of the compound, I have to take 1 calcium and 2 chlorines, their molar masses on the periodic table, and add them up, and I'll get a total. Then if I want the percentage of just the chlorine, I still have to take 2 times the chlorine and divide by the total. Now remember that the two percentages, the one for calcium and the one for chlorine, should add up to 100. And that's just close to 100. Now if you get an answer of 105, that's a little bit too far off. But 90, 98, 99, 101, 102, there you're okay. We're also going to look at some things later on in the chapter that are called hydrates. And this means that these are compounds that contain water molecules. Think hydration, you think you're drinking water. So hydrates have water molecules attached to them. It is hard to write out these hydrates in formulas since you have two compounds that kind of act as one thing. So they're written as two formulas separated by a dot. And there's always at least one water molecule per substance, with often a lot more than that, like 9 or 10. They are written like this, meaning they are 10 water molecules per one of these copper sulfates. So you see the CuSO4 dot 10 H2O. When you do the hydrates for the percent mass then, if I want to figure out the percentage of water in a compound, I take 10 times the water divided by the entire amount of the substance. That includes the CuSO4 and the H2O. Now, just because there's a dot there doesn't mean you're going to multiply. Don't multiply the CuSO4 and the H2O. Just add them together. Now go ahead and try a few other practice problems and check your work after you get done.